Hello friends, welcome to our channel. Today I will discuss another topic, that is a memory stack with a program stack and with program data and a stack segments. Means whenever we analyze memory stack, these three parts we need to describe. Okay, memory stack for memory stack. A stack can exist as a standalone unit, can be implemented in a random access memory attached to a CPU. That means stack, whenever memory stack will consider each it itself maintain own unity, and randomly they access different data which is attached to the CPU and operate accordingly. So independently that memory stack also do some operations and get giving some results or output. Okay. The implementation of a stack in the CPU is done by assigning a portion of a memory to a stack operation and using a processor register as a stack pointer. Okay. Whenever we go through some different operations, very simple operation, suppose arithmetic operation, that operation is done by the stack operation, and some processor register also we use, and that processor register also considered as a stack pointer. Okay. In the last lecture I have already discussed, that is a stack concept, how different items push into the stack or pop out any item from the stack, that I have already explained. So I hope you understand that previous lecture. So here what happens, whenever you go through any kind of stack operation, processor register considered as a stack pointer, and that stack pointer always keeps the data at the top of the stack. That kind of concept already discussed, but little bit just revise that. And another is computer memory. Actually, whenever we store some data or retrieve some data for any kind of operation, then that computer memory having certain segments. Okay, that segments will be considered into three parts. Okay, that segments contain three parts. One is there is a program part, another is a data part, another is stack part. Means a computer memory for any kind of operation, it is divided into three segments. That three segments defined in this way: program part, data part, and a stack part. Okay. All of you know that whenever you go through any program, then role of a program counter is important, because program counter points the address of the next instruction. Means it keeps the address of a instruction in the program. Whenever one instruction executed or execution of one instruction is completed, then program counter shift to another instruction. Means it keeps the address of another instruction for next execution. This is the basic concept of a program counter. So obviously we can tell as a program counter points at the address of next instruction or one by one instruction of the program. Since computer memory having three segments, we will discuss that three segments, how it will work or how it identified. Next is address register. And the data, normally data when stored in anywhere, means any data in memory, then it needs address register, because through address register memory can access the data. For that reason, address register points an array of data, because different data are there. So which data need to that is access and operate, that will be decided by the address register. So address register points an array of data. And another part is a stack. Okay, this stack is a stack contains the stack pointer at the top of the stack, which is very important, because whenever any operation is done by stack, only top position of the item need to operate, not in between, not in bottom or anything, any other in between top and bottom. Only top position of data need to operate for addition, subtraction or any kind of arithmetic operation. Okay, so stack pointer is important which is a part of that stack. So these three segments is defined in this way. First part is a program, next part is a data, next is a stack. Okay, and these the three registers are connected to common bus and either can provide address for memory. Why I am telling? Because here you see whenever individual that is a part segment we have to use, or those segments need to use as our requirement, then three register required. For first one is I told, that is program. You see I have already explained, that is first part is a program, second part is a first is a program, second part is a data, and next part is a stack. So for these segments we need, that is, three register, and whenever that register need to operate, then they can do accordingly. Okay, for the reason three register are connected to the common bus to operate that stack operations. Okay, this is the main concept, and either one can provide address from memory. And I have already told, if you go through first part, program part, so PC is used to identify the particular program or particular instruction, and initially what happens, PC is used during the fetch to read an instruction. The role of PC is just fetch or in the fetch page, PC just assign the instruction, starting from suppose instruction 1, 2, 3, any number of instruction. So initially it will assign, because I have already discussed, that is different instructions fetch in instruction cycle in last lectures. You can see that is how different phases are used to access the data from memory and evaluate accordingly. That part already over, so you can see that lectures. And since this memory stack contain three segments, so we will consider these three segments through three registers, and how they will work we will discuss today. Okay, now you see there is a first part is PC just assign the instruction, or just read the instruction from memory during fetch. Okay, after that what happens, next AR, address register, is during the execution phase, because whenever execution is started, and then what happens, it needs needs to read that is operand. If it needs operand, then address register help to find out where is the operand and collect that operand data and help to operate. Okay, in that case what happens, they will search for is operand through this address register. Okay, and next is stack pointer. Stack pointer is used to push or pop items into or that is on the stack. Okay, into or on the stack, that is a push and pop operation we use through stack pointer. Why? Because stack pointer is very important. It just keeps the data on the top of the stack. Whenever any operator is coming, then it will just operate on last or top two operand, either plus, minus, or any kind of operations, addition, subtraction, or any kind of operation through stack pointer. It operate. Okay, so if you want to insert some data, then we can use insert data into the stack through push. We can tell as a push, or a pop out means retrieve data from stack. Okay, this is the basic concept regarding on this particular stack pointer. and initially value of I will give some one example, then we can understand how it will work. Okay, now I will give some example, then through example we can discuss, it is better. Okay, I will make one stack concept at a memory stack. The top of the stack you can write a program, because we have already discussed that is a stack memory having 3 segments. Top of the stack is a program, and since the program contains number of instruction, it is identified by, that is a PC. You can write it is identified by PC. Okay, identified by PC. Next part is data. Data is kept by data register. Okay, data register, it will identify by data register, means data is kept by that address register, because it different operand is identified by address register, because each individual operand having individual address. So address register keeps individual data. Okay, and last one is that is stack. Okay, last one is stack. It is identified by stack pointer, SP, because stack contains a number of addresses. It is identified by stack pointer, because stack pointer identify the top position of the items. Okay, after that number of that is a number of sector address we can create, doesn't matter, we can create according ourselves, doesn't matter. Suppose this address is 4001, 4000, okay, 3090, 999, okay, 3998, 3997, 3996, and like this. Okay, let us consider 3000. Here is 2000, here is 1000. Okay, and this is the address actually. Okay, this is the address, this part is the address part. Okay, this part is the address part, and in bottom also, you see, in bottom also another part also there. I will tell you how it is defined. Since data register there also DR. Okay, that means data register also we will consider in bottom of that memory, because it is another register, it keeps the data. And how it is collected from data register through address register, and in this particular memory, then that concept is already there. We have already discussed that is a common bus, through common bus, how it will receive the data from data register, store in data here, and it will use in this particular memory. That part is over, because through common bus it will receive the data and send the data to the data register. Okay, now topic is this is the given this example, you just keep in mind. We will analyze how different parts like SP, AR, and PC use for memory stack. Okay, now see, initially what happens is SP here, very simply it is mentioned. Suppose initially value SP is 4001, means the bottom of the stack. Here you see bottom of the stack. Okay, 4001, and stack grows with decreasing addresses. Okay, actually stack is in a different reverse way, it is mentioned. Some memory having that is increasing order towards the bottom, some memory having increasing increasing order towards the top, like this. Like here is 1000, 1001, like this. Here is 4001, or reverse case also memory is defined in this way, different address depend on that memory, that is some configuration of computer or memory. Okay, if we go through this one, then you see normally what happens, increase the stack pointer, then we enter the data or push data into the stack normally. But here what happens, since it address is decreasing here, like this is 1000 2000, sorry, increasing in bottom, then what happens, it is increasing, sorry, decreasing the address, like whenever top position stack pointer is increasing or decreasing this stack position, then stack point, that is space will be vacant, then we insert some data. Okay, reverse case, actually here to mention reverse case, it depend on the that is I told that it depend on the configuration of computer systems. Okay, here you see initially what happens, stack pointer suppose here 4001, then whenever stack pointer is decreasing, here SP, here is bottom is 4001, be decreasing, SP is equal to, for example, SP is equal to SP minus 1, then it is decreasing. Okay, then what happens, this space or pointer point to here, suppose pointer here SP here, according to this rule SP is equal to SP minus 1, so SP shift to 4000. Okay, for example, SP now is 4001, next SP will be 4000. Okay, next will be 4000. In that case what happens, we enter some data, because SP currently it was 4000, when shift to here means for SP minus 1, that is 4000, we can enter any data from here. Okay, this is the basic concept. It will depend on that, means based on that stack address how it will be calculated. Since it is increasing order towards the bottom, then you will calculate SP is equal to SP minus 1. Suppose reverse case, here is 1000, 1002, 1001, 1002 and 1003, like this, of here is 4001, then it is increasing order like this. Okay, now we see so if that is initial value is 4001, the stack grows with a decreasing addresses, no problem, that is a decreasing address. Okay, and first item stored in the stack is at address 4000, and a second item similarly, here you see, here is first item, here second item 4000, next item 3999, and next address similarly 3998, like this we can insert some data into the stack whenever decreasing the addresses. Okay, for the reason it is mentioned like first stored the stack at the address of 4000, second is stored at 3999. Okay, like this, and the last address stack of the stack is the last address is 3000. You see the last for stack is 3000, so up to 3000 we can insert some data. Okay, so here you see that is the last address which we can take. And another is no provisions are available for stack limit checks. Okay, no provisions, here mentioned no provision. If it is a fixed stack, then we have to find out what the top of the stack, it is full or empty. We will see that. I have already discussed in that part how stack is full at what situation or it is empty at what situation, that we have already discussed. Okay, next you see very simple way I will show you. Suppose we insert some data or something, we update the data like this. Okay, how it will update? We assume that items in the stack communicate with the data register DR, because we have to enter some data into the stack, so we collect the data from DR. Okay, data register contains the data, so stack communicate with the data register. Okay, stack communicate with the data register, and a new item. Okay, new items inserted into the inserted with the push operation as follows. How? I have already discussed. Here you see very simple way. Whenever go through that stack, here I already discussed this part. Here it is DR. Okay, whenever enter some data into the stack, the data collected from DR and stored in the stack. If we insert operation use or push operation use for the stack. okay, because stack here, suppose here 4001 and increase is position, sorry, decrease in position, and this SP, this will be vacant because data is here. Whenever SP will in decreasing here, then this space will be vacant. Then what happens, data collect from or data transfer from DR and insert into this particular position, this position it will insert. Okay, this is the basic concept. And whenever data will delete or pop out, then data also transfer from these two data registers. Okay, I will show you how the what is the equation, how it will work. Okay, data transfer, if you pop out, then suppose pop out, the SP will be increasing because this is the address decreasing towards bottom, so SP will be increasing. In that case what happens, this data also store in a data register. Okay, if SP is equal to SP plus 1, because this is decreasing order, sorry, increasing order towards the bottom. So whenever SP is equal to SP plus 1, here is the SP is there, suppose here SP is there, SP is increasing, that is SP will be here. Then what happens, this data will be deleted automatically and store in a DR. Okay, store in a DR. So this is the basic concept. Okay, for push of data or insert data into the stack, SP is equal to SP minus 1. If we pop out the data from the stack, then SP is equal to SP plus 1. In this way, we insert some data or delete data from stack through a DR register or data register and from stack. Okay, this is the basic concept, and some instruction I will show you how it will work. Here you see SP is equal to SP minus 1, means decreasing, because towards the top it is decreasing, and data, memory data, here there is a data register, that content of the data stored in a memory of SP. Okay, because SP is there, I told that is SP is there, very simple, here SP is there here. Okay, we have to insert some data, that means SP is decreasing, here in this part SP is decreasing, and store here data transfer from DR to memory of SP, because we can write very simple way, that is memory of SP. Okay, where is SP, because it is total is memory, stack pointer, memory of stack pointer, we insert some data from that DR to here. Okay, whenever pop out, then it is a pop out to this DR. Okay, so in this way we can, whenever pop out, then what happens, you see pop out means what will do, data the address will be increasing. Here pop out means address will increase, SP is equal to SP plus 1. Whenever SP, suppose SP is here, SP plus 1, then what happens, it is address come to here, and suppose 4000, it is come to 4001, automatically this data it will be deleted and store in DR. Then SP, then we can also write here DR keeps the data from SP, memory of data, that is memory of data, that is SP, what data is received or kept, that is transfer to DR. Okay, that is transfer to DR. So in this way data is inserted or deleted from stack, very simple way it is mentioned in this way. Okay, so top of data here is very simple, just data register keeps that that pointer, means stack pointer keeps the stack pointer data transfer to DR. After that SP will increase. Okay, that means top data or items read from stack, here top data read from stack and into the that is DR, because that is transfer, here is it data transfer, because this is the read operation. I have already discussed one class, whenever data transfer from memory to any other register, then that in this way data transfer from memory to any other register, then what happens, we can tell as a read operation. Through read operation data transfer from SP to memory of SP to DR. Then stack pointer is incremented at the point of the next items. Okay, so in this way automatically that is stack pointer is increasing, because towards the bottom it will increase. So in this way that is a stack is in maintained in for inserting or deleting. Okay, any kind of data delete from stack or insert into the stack we will go through this kind of instruction. Okay, thank you very much. I hope all of you understand this topic. The topic was that is a memory stack with a program and data and stack. Okay, this is the basic concept I explained. So I hope all of you understand this particular concept. Okay, thanks to all. Please subscribe my channel. If you want to give some comments, you can give. Okay, thanks to all.